Okay, when you want.
Okay, so I'll start. Hi everybody, we are Alex, Fran, and Marcos, and today we're going to talk about event sourcing. First, let's see what it is and how it works. Go to the next slide. Okay, the fundamental idea of event sourcing is that of ensuring every change to the state of an application is captured in an event object, and that these objects are themselves stored in the sequence they were applied for the same lifetime as the application state itself. We can see in the diagram a general view of this idea. The user will cause some kind of event which will go through some processes, changing its properties and its internal state, storing the object every time we apply one of these processes. Go to the next slide. Okay, now let's consider a simple example to do with shipping notifications in order to better illustrate this concept. In this example, we have many ships on the high seas, and we need to know where they are. A simple way to do this is to have a tracking application with methods to allow us to tell when a ship arrives or leaves at a port. In this case, when the service is called, it finds the relevant ship and updates its location. The ship objects record the current state of the ships. Now, let's see how we would apply event sourcing to this system. Introducing event sourcing adds a step to this process. Now the service creates an event object to record the change and processes it to update the ship. Looking at just the processing, this is just an unnecessary level of indirection. The interesting difference is when we look at what persists in the application after a few changes. Let's imagine some simple changes. The ship King Roy departs San Francisco. The ship Prince Trevor arrives at Los Angeles. The ship King Roy arrives in Hong Kong. With the basic service, we see just the final state captured by the ship objects. The most obvious thing we've gained by using event sourcing is that we now have a log of all the changes. Not just can we see where each ship is, we can see where it's been. However, this is a small gain. We could also do this by keeping a history of the past port in the ship objects, for example with a list, or by writing to a log file whenever a ship moves. Both of these can give us an adequate history. The key to event sourcing is that we guarantee that all changes to the domain objects are initiated by the event objects. This leads to a number of facilities that can be built on top of the event log. Let's see these facilities. Complete rebuild. We can discard the application state completely and rebuild it by rerunning the events from the event log on an empty application. Temporal query. We can determine the application state at any point in time. Notionally, we have to do this by starting with a blank state and rerunning the events up to a particular time or event. We can take this further by considering multiple timelines, analogous to branching in a version control system. And event replay. If we find a past event was incorrect, we can compute the consequences by reversing it and later events, and then replaying the new event and later events. Or indeed, by throwing away the application state and replaying all events with the correct event in sequence. The same technique can handle events received in the wrong sequence, a common problem with systems that communicate with asynchronous messaging. A common example that uses event sourcing is a version control system. Such a system uses temporal queries quite often. Subversion uses complete rebuilds whenever you use a dump and restore to move stuff between repository files. But enterprise and applications that use event sourcing are rarer. Now Alex will continue with the benefits.
Yep. So now I'm going to talk about some benefits of using event sourcing. So as we all know, by now, event sourcing uses a log, or also known as a ledger, to store every single event. Main uses are for inventory or catalog, as we've seen before with the ships. But now we're going to dive a little bit deeper into the benefits, which are not that many. Increased data quality. So as we're using the same events for the analytics that we're storing in the log or the ledger and for other feature teams, the quality of the data is improved for machine learning. We have relatable architecture. So when using event sourcing, the design of the architecture matches more closely what occurs in the real world. So, for example, with the ships, it is something that actually happens in real world, and we are transposing it into code. So these events will also be shared in the next slide. We have some examples so you can more easily see how it works. Quick reaction. So quick reaction is that the reaction time is pretty fast when using event sourcing. It is more or less 2 seconds. We also have scalability. So if the base architecture is well designed, it is easily scalable to thousands of events per second, and adding new event consumers is really easy. Service provisioning. Service provisioning is the strong decoupling of services, which reduces the time that it takes to add new services or change old ones in our program. So this lets us easily be able to change a new service, discard a new one, or whatever you want, or just change it. Historical record. So super easy. We're storing our events in a log or a ledger, so we always have the transactions recorded in a way of in a data line. So now I'm going to show you some examples of event sourcing used in real life. We have a game of chess. Every single move is recorded into the log of ledger with the information that we need. So if we're moving the king or we're moving the horse, we're always, every single move, storing the movement, the player that does it, the piece that is moved, and to where it is moved, and the actual piece that it is on. So if we have ended the match and we want to review it, maybe we can go to step number 2 and just see where all the pieces are, what you could have done different, what you could have changed. It is easy to go backwards and front as we have the log with every single event. Another maybe easier example is a shop. So every item that is sold, exchanged, maybe sent back is recorded into the log in maybe this format. So if we exchange a shirt, the shirt exchanged and the price which the shirt costs. For example, if we're selling an item like a belt, is sold for $45 to the customer number 55, and everything like this. Some examples where event sourcing thrives is serverless architectures, which we will see with Team 10, and Internet of Things.
Well,
Now,
it's my turn. Yeah. So now we are going to do a brief summary about the experiences of a software developer with event sourcing, because I think that the best way to learn is with example. Next slide, please. Well, from the outset, the first thing we tell us is that event sourcing is difficult. You need some knowledge about it because it has a point. It seeks to get into the transmission of events and return the data you need. So, in practice, is extremely coupled. The idea of keeping a central log with multiple services can subscribe and publish is insane. You couldn't let to separate services reach directly into each other's data storage. If we don't use the event sourcing approach, we will pump them through a layer of abstractions to avoid breaking every consumer of your service when it needs to change data. However, with event sourcing, we pretend this isn't the case. If you fix it, you are going to have another issue, the opacity. Now you have like a observed pattern where control becomes inverted in a way that makes it difficult to know how actually data flows through the system. It is a fairly slow process. It is created from scratch and it will have several implementations since you are learning with the error and thus to be able to finish with a sufficient base where to start. Then another problem is finding a full development team. Yes, disagreements will grow between all. It doesn't matter the field since they try to discover the best way to make the system maintainable. And finally, the important point is that each project is something new. All is heterogeneous, so probably things that you implement in some place you couldn't use in another implementation. So with this, we finish the presentation. Thank you for listening. And now there is some questions.
Okay.